The distance between the discs in discs harrows is crucial for the quality and efficiency of the tool's work. The disc harrow is mainly used for breaking soil clods, tearing up stubble, mixing plant residues with soil, and preparing the field for sowing or planting. Choosing the right distance between the discs depends on several factors. Soil type. On heavier, more cohesive soils, discs placed closer together can more effectively break up soil clods. For lighter soils, a greater distance between the working elements can be more effective. Task. If the goal is a deeper soil mix, then discs placed further apart will be less prone to blockages. For shallow work or just breaking the topsoil layer, a smaller distance between working elements will be appropriate. Type of plant residues. In presence of large amounts of plant residues, discs placed further apart will help mix them more effectively with the soil. Harvest residues need more space to prevent clogging. Tractor power. The closer the discs are to each other, the less tractor power is required. A larger spacing of working elements means a heavier machine and greater demands on the pulling tractor. Frame clearance. This may affect the penetration depth of the discs in the soil, which in turn affects the effectiveness of tillage. Technical condition of the harrow. Over time, as the discs wear out, they may lose their original diameter, which can affect the distance between them and the work result. Coupling to accompanying machines. Disc harrows with a smaller disc spacing can often be combined with seeders to create a tillage seeding set. The diameter of the disc harrow discs is crucial for its field performance. Here are some points regarding the importance of disc size. Working depth. Disc diameter affects the depth to which the harrow can penetrate the soil. Larger working elements can work deeper than small ones. Additionally, their service life is usually longer and the material they are made of is thicker. Working force. Larger discs may require more tractor power as they create more resistance during work. Crushing. Larger discs can better crush soil and post-harvest residues, while smaller ones may be more suitable for shallower surface work. Working speed. Depending on the soil and conditions, a smaller disc diameter may allow for faster work. Clogging resistance. Larger discs may be less prone to clogging in the presence of large amounts of plant residues. Application. Smaller discs may be more suitable for delicate tillage or where you want to leave some residue on the soil surface and for field preparation for sowing. Larger working elements may be more suitable for thorough tillage and more effective in mixing residues with soil, such as post-harvest corn tillage. The angle of inclination of the disc on a disc harrow refers to the angle at which the discs are set relative to the direction of travel and the soil surface. This angle is important because it influences the efficiency of the harrow and the quality of soil processing. Several aspects regarding the angle of inclination of the disc. Intensity of tillage. The greater the angle of inclination of the disc, the more intensive the tillage. Working elements set at a higher angle will more aggressively enter the soil and turn it over. Weed control. A greater angle of inclination of the disc can be more effective in destroying and covering weeds. Shredding residues. The angle of inclination can affect the ability of the harrow to shred and mix plant residues with the soil. Working depth. The angle of inclination of the disc affects the depth at which they penetrate the soil. A larger angle usually means shallower work with good cultivation results, where a machine with a smaller angle of attack must work deeper to achieve a similar effect. Harrow clogging. In certain conditions, especially with a large amount of residues on the surface, A larger angle of inclination of the disc can increase the risk of clogging the harrow. Disc wear. Aggressive angles of inclination can lead to faster wear of the discs, especially in hard soil conditions. Purpose. Machines with discs mounted at an aggressive angle are more technically oriented towards post-harvest cultivation, where machines with a moderate angle are intended for both pre-sowing and post-harvest cultivation. To summarize everything that has been said before, choosing the appropriate angle of inclination of the disc will depend on the type of soil, the presence of plant residues, the purpose of cultivation, tractor power, and other important factors. Rolmako offers a full range of disc harrows with various disc spacings, diameters, thicknesses, and angles of inclination. When choosing a disc harrow, it is worth considering the type of soil, cultivation method, available tractor power, and personal preferences regarding soil cultivation quality. It is also worth consulting with the manufacturer or equipment dealer to precisely match the tool to your needs. There is no single universal cultivation machine that will meet all field needs, just as there is no single solution that will solve all the problems faced by agriculture. Therefore, Rolmako agricultural equipment offers flexibility and customization, allowing farmers to adjust the equipment and select working elements for a specific type of cultivation, soil type, and the expected result. Our products are designed with the individual needs and preferences of each farmer in mind to ensure optimal results in field work. If you want to learn more about the various plowing elements and their applications, we invite you to visit rolmako.com working elements. There you will find detailed information about different types of working elements, their compatibility with our machines, and their potential for various cultivation techniques. Discover the wide range of possibilities offered by Rolmako and choose solutions ideally suited to your needs.